So sadly, this is the second um stream, or no, actually not a stream. This is the second recording I'm doing of this whole thing. Um, it's just crazy. I'll have to do it again, and the reason is because after recording um the entire thing, I realized that I had a setting in my OBS studio that made the recordings have like lossless quality. So the quality was so big, the video was 31 gigabytes, as you can see here, or 35 rather, gigabyte of data for that video. And how many videos played? Let me see what's up. Hey, yeah, so I want to go over this. It's 18 minutes video, 31 gigabytes of data. I can't send it to you on Gmail. I can't upload it to YouTube. I mean, I can, but I mean that would take a lot of data. So I mean, it's just too much. So the best thing I can do is to go over the whole thing again. So crazy. I know. I just have to do so. I already wrote the code, run it, tested it right here. Um, I'm just gonna create a new one. Go over the whole thing again. Shit, it's gonna be crazy. So I'm gonna name it LCP2.py. I'm starting again. So here's how I want to solve this. I'm going to take the first word in the list. Then I will loop through each character of the first word and compare it against the characters in the rest. I'll take the first word, in this case, which is flower. Then for every character in flower, FLOWA, I'll pick that character, which for the first iteration is to be F, and I'll test against the remaining words in the list, flow and flight. By testing, I'll take the character F, which is at index 0. So you can see the index is very important here. And I'll use it to check if the character at index 0 of flow is also F, and the character of index 0 of flight is also F. If this condition is true, I want to add this to my results. Then we go over the next, we go to the next letter again, L in this case. Compare, which is true for our first example. And then I'll put that character L in our results, FL. And then we go to the next character, which is O in our case. And then we'll test against flow. By the way, O is at index 2. So getting the character at index 2 in flow, I get O. Getting the character at index 2 of flight, I get I. Given there's a mismatch, I'll terminate the loop and then I'll return the results. Now keep in mind that this implementation requires a nested for loop. And that would mean we need a way to break the outer for loop. Because if we break the inner for loop, which you see in the code, if you have a nested for loop and you break the inner for loop, the outer for loop still runs. So we need a way to break the outer for loop when we realize that the inner for loop was broken. So I believe there's a way to do this in Python with else statements for else. I would like to use that, but I think it might get you confused. So I won't use that. If you want to look into for else, you can check it out. But for this video, I'll be as plain and simple as possible. So let's begin. So let's get longest common prefix. Just simply going to create a function. I hope you can see the screen. Let me make this bigger. So yeah, that's a bigger screen or bigger text. So we are going to create a function. We name it longest common prefix LCP. So we're going to take in a variable. I'm just going to call it strings, as is right here. So this is a Python function, as simple as it can be. But to further make things a bit more advanced, readable, and obvious, I'm going to include annotations. I'm going to specify, by the way, annotations should actually use less in runtime. Not always, but I don't know. For most cases, yeah. I'm going to say that I'm taking a list of strings. And I'll denote that by typing list and a square bracket string. That would mean that strings right here is a list of strings. And I'm also going to denote that we are returning a string at the end of the loop, or at the end of the function. Use that by by writing a hyphen and then a greater than symbol, and then point to the type that will be returned. So that's it for our loop. So or rather function like that. So what I'm going to do here is get the first item. Now, why are we getting the first item in the first place? Um, for this loop, or for to check, or let me put it like this: the longest common prefix can never be more than, or can never be more than the size of the smallest item in the list. So here we have flow right here. The length of the output can never be more than this flow, which is 4. And the reason is because, let's say we had, let me copy this. Let's say we had flower, flow, and flows. The longest common prefix here would be flow. And that is because after this W here, here we have E, here we have nothing, here we have S. So it's not common anymore. So the smallest we can get is W. So for in order for us to actually compare one guy against the other, we don't need, but the least we can get is the smallest length, the word with the smallest length. But given that we can just ignore that entire, you know, thing, because we can get the flow also in the biggest. This whole thing might get you confused, but it's not like really crucial. The point is, it doesn't really matter. I'm just trying to make a point that it doesn't really matter the item we picked or we pick, and that's the reason why I'm just picking the first guy. So we can just pick the first guy, and we still have flow. We still have like at least length 4 in this guy, so we can actually test at least 4 times in every item in the list. So we can just pick any guy. It doesn't really matter which one we pick. So that's just the point. If you don't understand, you can just don't worry. Just know that we can pick any random item in the list. So I'm just gonna call this first item. And it's going to be strings 0. Also, we need a place to store our results. So there's going to be an empty string for now. And then at the end of our function, we just return the result. So here, like I said, we need to compare each of the characters with the rest in that same index as the character. So, for example, here we have flowers. This is our first. So we have f at 0. We need to check if the character at 0 here is also equal to f. So you can see we need the index of the, you know, we need the index of the character we're going to test. So now let me show you two ways to get the index while using a for loop. The index and the character. So I'm just going to create a new let's run IPython so we can have an interactive shell. For our case here, I'm going to introduce items. I'm going to point it to this list. So now we have items here, right? We need a way to get the item in items and also the index of the item. So how do we do it? Uh, I'm going to not use items as an example because I want us to see like if I get to in this case a word. So I just want to see a word, an actual word in action. Let's say I'll point to word. So I want to in the like loop through. I want to get the index of a character and also the index. Oh shit, my bad. When you use a for loop, you do for character in word. When you print character, you get FLOWER. This way, you get the items in the iterable. But how do we get the index of the item? There are two ways we can get this done. First one is if we use range. So we can actually look through range. So we look through range, let's say 3, and print I. We get 0 through 3, but 3 will not be included. We get the first 3 numbers from 0, 1, 2, 3 numbers. So this way we can actually look through the length of the word we're trying to get the index. So we can just pass in the length of the word here. So this way we can get the number 0 through the last index in that word. So if we do print I, comma, disable, just create a variable for this. So since we have the index, we can just get the character from that. And we can just print the character. So you can see here, we're able to get the index and also we're able to get the item. Another way we can get it done is use enumeration. So if I add the words right there, I say enumerate. What enumerate does is it takes your iterable, at least like an iterate over, right? It takes your iterable and then it gives you a list. It gives you a list of tuples. That tuple holds the information for your index and the character representing that index. So we have enumerate word here. If I run this, I get an enumeration object, but we can convert this to a list like this. And we can see that it holds the first item is 0f, which represents the first item in word and the index of the item. So we can also do this. We can loop through. We can iterate about our enumeration objects by writing this. It's going to be index character enumeration. enumerate word. So we can just print I character. So you see, we get the same results as we did here. So that way we can also get the index of the character in the iterable. So that's what we're going to do here. Let's say for index character in and enumerates the first word. So yeah, like I said, we're going to loop through each of the characters in the first one and compare it with the rest. So now we're able to get f, which is stored in character, and also the index of f, which is stored in index. So here, I can now do a test through the rest of the item. So given that we already have this guy, right, I don't test flower against itself. I want to test flower against the rest of the guys. I'm actually going to have to slice this list. And let me show you how slicing works. So we want to slice this list, right? Let's show you an example. Let's create strings. I have this list right here. So I want to get from the first item down to the end of the list. I'm going to slice it this way. So the first item, the first index down. So we do not like this. I want to look through arrays and slicing if you don't know how to do this yet. But for now, we're just gonna move on. So for word, since we now want to test this guy against these guys, but we're going to have to do another for loop. For word and strings, getting the first item down. That means we now have flow flight for each iteration in word. So here, what I want to do is check if the item at this index or the character at the index in the word is equal to the character we have at hand. So if word index is equals character, what this means here is for the first iteration in this line 6, word is flow, right? And then if we're testing f, which is at 0, I want to check if word, which is flow 0, which will give us this f here, is equal to f. That's what's happens. That's what's happening here. So we get the words index equals char blah blah blah, and then so if this is true, we want to just continue, right? Because we need to test the next guy. But then if this is not true, what we want to do is break the loop. Let's break the loop. So I'm going to create a so I'm going to create a variable to hold the current character or not. I'll show you what I mean. Give them its rest chunk. So there's going to be a string or none. I'll explain why in a bit. So by default, it's going to be equals character. So that means after we are done with everything here, we want to add rest chunk to results. But if for any reason we break the character, that means if you get to this point here, where this is I, as if one index is not equals character. So our character we'll be dealing with at this point is O, but at the same index we are getting I. So since O is not equals I, what we want to do is break it. We want to set rest chunks to none because at this point rest chunks is not O anymore. We don't want it to be O anymore. Uh, in index one where we have L here, rest chunks will be L. When we compare this here, we still have L because we're not updating rest chunks. Same thing here, we still have L. But in this case, because it's not the same, once just set rest chunks to none. So I can just do rest chunk plus none. What this will do is just remove the value from rest chunks and set it. So we are going to break this. And then after we're done with this big for the inner for loop, after we're done with this for loop here and we come out, if rest chunk, so if we find any index where we don't get similarity between characters in the same index, what we want to do is just break the big loop since we are done with our task and just return whatever we have. So if rest chunk is none, just return results. So this will break the loop and get another function. Well, if it's not none, I want to add rest chunks results. So this is where we get succession F L blah blah blah. So we'll add the chunk. Oh, it should be rest. We'll add the chunk to our result. So basically, this should be everything. I think we'll run into an issue where there would be, given the length is not the same, right? So if if we had flower here, and then like for some weird reasons, we had to um also check. For example, like let's say this was flowy. Let me show you an example. So if you had something like this, here's where the issue is. When we get to index 3, which is W here, we can compare index 3 with its flow and also compare index 3 with this flowy right here. To give us W and also give us W. Well, when we now move on to the next index, which is E for 4, I'm going to test against flow and flowy. We can't test index 4 because there's no value at 4 here. There's no value at 4 here. The maximum index we can give to this guy is the length minus 1, which is 3, which is W here. So if we try to index 4 against flow right here, we're going to get an index error. Let's first run this to see if it works. I've got to test it against actual test case. I think this should work because I'm going to stop indexing at L here because when we index against 2, which is O, O, we get I here, which just breaks everything. So we just return this. That's the step. So I run this. Oh my bad. Yeah, yeah, I fell. So like I said, that's um issue that I brought up. We have some like flows. Yeah. When we test against this flow, and then we want to test E. So is that index 4? When we want to index this guy against 4, it won't work because there's nothing here. There's no item here. So we're going to get an indentation error. If I run this, yeah. So rather index error, my bad. Slip them high. Why is that heavy like crazy? So that's because we can't index flow with 4. So if for any reason the index is equal to the word, to the length of the word, which in our case here, if index is 4, we can't index 4 against this guy. If index is 4 for flow, yeah, what we want to do is just break because there's nothing to check anymore. So that is going to have the same effect as this condition here. But let's say if the length of the word is also equals to the index, which should be impossible, we want to do the break. Or you get my point. So if we get to the last, if we get to like, if we already check for almost every guy, which index here should can never be the same as the length of the iterable. If that is the case, that means we're already out of the iterable. So if we get to that point, we want to break this, or we do the normal check. So if we run this, we should get flow, which, like I said, is the smallest. Like this is the maximum output you can get is the length. The maximum length of the output you can get is the minimum length of the word in that list. So if I save this, we should get flow. So yeah, probably going to upload this to YouTube. Not because I think I kind of put some efforts into this. Um, I'm hungry and I'm sleepy. I'm tired, so I'm going to rest now. Have a nice night. I hope this was not 30 something gig again.